It's my continued pleasure across this entire day to introduce Colin Murphy from Adobe, who's been bringing wasmCloud to Adobe's Kubernetes infrastructure. Again, don't want to do too much spoiling. So, Colin, I'll just go ahead and give it to you. You should be able to share screen and all that stuff.
All right. Thanks, Brooks. Yeah, everybody can see it. I stupidly updated my my operating system right before this. Okay, so everyone can see this is Adobe Express, which you can do presentations from. Just throwing out that out there, working on this. Okay, so my name's Colin Murphy. I work at Adobe. I think most of you have know that by now. But yeah, so I'm going to talk about C plus wasmCloud. And hopefully we can slide. Okay. So we don't have a lot of examples in the wasmCloud examples of C, or we have no examples in wasmCloud examples of C. We have no examples really anywhere for C, a C WASI service. I did, in the course of this, did find one example in a gist, but other than that, there really is not a lot. But we should, you know, we should have C and C++ examples. We should, because first off, in the embedded space, in the applications, desktop application space, in the gaming space, C++ is still the king. You know, all of the Adobe Desktop software, all of our WebAssembly is written in C++ with the small exception of the Content Authenticity Initiative, which is written in Rust. And we have a lot of WebAssembly users out there for Inscription, and we want them to write WASI applications as well. And then another reason why C and C++ is a good thing to support in wasmCloud is because it's supported in WASI. Although not many examples, but there's the WASI SDK, and it's been built into the Clang compiler, so it's there. So we just have to kind of expose it and give good examples for people. The use case that I made for this example was PDF. So I wanted something that was technically challenging, a little more than just Hello World. And PDF is, because it's really taking something you'd send to a printer and putting it into something that can be rendered on a monitor. So back from the 90s. I've actually got behind me over here is the guy who came up with it. So it's technically challenging. There are lots and lots of implementations. They're all written in C or C++, and they're of varying quality. And third, this is something that we probably want at Adobe, but there's a lot of PDFs in open source format. There's a lot of use cases for running PDF functionality. You know, we call them verbs on the edge and in various places. So so that was why I thought PDF was a good example. The first, yeah, I'm just going to go through it. I'm just going through how I did it. I had to find a PDF library. I wanted it to be open source so I could put it out there on the web. I wanted it to be somewhat functional so that I wouldn't get in trouble and by changing it too much. And it had to be written only in C just to make it easier for Clang and WASI. C++ with a lack of exception handling and various things in WASI. It's just easier to just go straight C. Although not impossible to do C++, but I only had a few days to do this. And it had to be able to open PDF files, which is actually something that not a lot of libraries out there do. There'll be a lot of creation libraries, but not a lot of just opening an existing file. And I wanted to be able to give it a PDF and have it spit out the text of the PDF. So to generate the bindings, so I used with BindGen, just like it's built into Wash for the other languages, but not yet for C. So I just had to generate the bindings for C, and then the third part is get it working, which is always 99% of everything. There was that one gist I found for implementing HTTP incoming handler. That example that just actually did not work, but it was pretty trivial to get it working. The real challenge was modifying that PDF library. So all PDF libraries use file handles because it's been around for 40 years, and so there wasn't a lot of working memory when PDF libraries came out, and PDFs can be very large, and so they're used to working with PDFs on disk. That doesn't work for WASI. First off, it gets kind of complicated because we have OpenAT, right? We don't have the full suite of file opening and writing capabilities by design. So I had to use a memory buffer. So I'm gonna post the whole PDF, and then it exists in a memory buffer, and then I needed that PDF library to work on it in a memory buffer. Oh, and I lost my mouse. Yeah. Okay. So as I said, that was kind of the big challenge. So just emulating what a file handle could do. So fseek, lseek, open, read. I didn't do writing, but kind of do that. The standard sort of things. Maybe we can build those build some kind of functionality into the WASI SDK or wasmCloud. The other kind of challenge was that when you generate the bindings, and maybe I'll show that if I have time, there are a lot of Rust concepts. Well, there's the main Rust concept of owning and borrowing, and those create duplicate functions. I don't know why fown got in there, sorry. It's just supposed to say own and borrow methods and types. And there's also lack of namespacing, right? So I can't, so the methods and types of the package get, well, I guess pre-appended is added to the beginning of the methods and types. And so it makes it so it's kind of harder to, it's harder to kind of make an example that everyone can use when the name of your package is on every single type and method. But I did, there's a PR I've added to the wasmCloud example, or I've opened to add a C example. So you can all see that. And then dependencies are always really hard in C and C++. Anyone who's done C and C++ knows that. Lots of times there'll be one build tool chain for one package and another for another, and it can be really, really terrible. So really what was nice with this library I chose, PDFIO, the only dependency was zlib, and you already know that works in WASI. So that was very fortunate. I do want to demo, and then if we have time, I'd like to go over some of the kind of in-depth, a little more of the challenges I faced. So everyone can see still. Somebody Slack me if you can't. So here, yeah. So we've got I've got the PDF text. I made a WADAM file, and just really copied it from the Rust example, hello world. And I've just got a little component, and I've got the server, and I have I just have the basic PDF I'm going to give it, because it was actually a limitation in the library, not WASI, that this thing can't handle pictures or any sorts of bounds or anything like that without crashing. So this is a very minimal example, and then here we go. I'm just going to send that post, and yeah, and so I get out. This is, as you can see on the bottom, this is a test PDF. There's more in this example that I included. There's more in this little thing, and also I included in the example in the PR, just to kind of work through how what's in that request, what that request comes in as, because it's C. You're doing some. It's not nicely packaged for you, the headers and such. So here is the. I will. Okay, having a hard time. Sorry. Okay. I was sharing. I had a window because that's how I did the presentation. But whatever. Okay, so here it is. Anyone can go grab it. And you'll find that it's all in here. There were some changes to PDFIO, but you do kind of see that this is this is a lot more. There's just a lot more stuff you have to deal with in C. A lot of like pointer casting, things like that to read headers. So it's not as easy to get started. And I lost my presentation. Okay, so I don't know. Are there any? If there are any questions, I can talk about those now, or I'll try to get my presentation back. It was Chrome's fault, not Adobe Express's.
Good save there, Colin.
Yeah, yeah.
Um,
Here it is.
yeah,
Okay.
go for it then. I'll hold my
Yeah.
question.
All right. Thanks. Thanks, everybody. Right. So it was actually me probably pressing Command W. Okay. So there were a few, and maybe this will spur some questions, but the challenge I really banged my head against was LLVM shadow stack memory. I kept rolling over the pointer on the stack because there was just so much the depth of function calls got to the point where for a 32-bit system with a 1 megabyte stack, it's pretty easy to roll over the stack pointer. So it's a little confusing because there's a stack pointer in LLVM and there's also a stack pointer in Clang, and you have to make sure you set the right stack size. So thanks to Pat Hickey on that one. The other thing Brooks helped me out with was the blocking read and write. That's in the Rust examples, but I forgot about that. You actually can only read up to, I think, 4 kilobytes at a time in the HTTP handler. So you have to keep looping, and then when you write, you have to keep looping through and writing out. Using wasm times serve was really useful. I know we're getting there with wasmCloud host, but wasm times serve was a little more verbose when things went bad. And then I work on this on my Linux machine and on a Mac, so that could be a challenge as well because Xcode and system libraries and stuff like that are in different places. But I made it so it's all in one. It's an all-in-one package. You don't have to. There are a few things you need, but there's just a make file, and it just builds everything. So it should be not intimidating if you want to test it out. And maybe somebody can get PDF.io to be able to actually take text from complex PDFs. All right, that's it.
Colin, this was super cool to see. I don't know, kind of just like the whole flow through like use case to finding PDF library to turning that into a component. Um, I'll be the first to thank you for stubbing your toes so that we don't have to. I did want to ask, maybe let me know if you can share this. What's the plan for this component? Like now that you have this component that's written in C and processing PDFs, and you can deploy it on wasmCloud, where are you going from here with this app?
Yeah. So what I'd like is to hopefully get well, I have some traction, but build some momentum within Adobe for our own proprietary PDF libraries to build this out into a component. I don't want to say too much more, but if you can filter out if you just are looking for PDF text for a given application, passing an entire PDF is expensive in network costs and user time. So if we can process that stuff out on the edge, especially for mobile or small devices, that can be really useful. We have, as I said before, we really think of PDFs in terms of different verbs and different actions with PDFs, and if we can compile each one of those actions into a different WASM component, it should give us more flexibility.
Yeah. Quick, maybe dumb question. How big did this component end up being?
Oh yeah, I didn't. Sorry, I had my day job got in the way. Too much Express. I got it to 947 kilobytes, but I did not compile it. I did not optimize compile it. So it's less than a megabyte without anything stripped out. So hopefully much smaller. Sorry, I didn't mean to do that.
That's super. I mean, that's great to hear. Like a Rust component, I think usually comes in at about like 2 megs, and then once you strip debug symbols, it comes in, anywhere from like 100 to 200 kilobytes. So I bet this one is probably pretty small once you do
Yeah,
like minus. That's pretty
I'll do.
cool.
I'll see if I'll have it for. Come to the Hangout, and I will have stripped out everything and
Oh,
optimized
nice.
build it.
Yeah, you gotta come to the Hangout to see
I'll give
the
it a Hangout.
final component.
Yeah.
Um, all right. Well, let's see. I didn't see any additional Q&A. But I think we can go ahead and wrap this up and start moving on to the Hangout. Thank you so much, Colin, for again taking time away from the day job and away from what you're doing to present here. It was really nice.
Yeah. Thanks.